Hello and welcome everybody. Robert Frawley here from TechCrunch. Our webinar today is Real-World Resiliency, Surviving Data Center Disaster. Leading today's webinar is Stanislav Komanets, VP of Engineering Platform at popular European travel site, Kiwi.com. His talk today is about Kiwi.com's ability to continue operations uninterrupted despite one of their data centers literally burning to the ground. So this will be a really interesting discussion today. Today's session will run about an hour, and following the presentation, we will have a live Q&A session. Please put your questions in for Stanislav in the Q&A panel located on the right-hand side of your screens. This presentation will be available after the show. And without further ado, please take it away, Stanislav.
Thank you very much. Thank you very much, Robert. Hi, everyone. Thank you for having me. I'm really happy that today I can share our story about the building the resilient system in face of the data center disaster. But first thing first, let me introduce myself. I'm Stanislav Komanets. I came to Kiwi 6 years ago, and I started working here as a backend developer. One of my first jobs was like taking care of the manage my booking system. So basically the system where customers could manage their booking, handling changes in the itineraries and trying to get refunds and so on. And that time we were still in heavy startup mode. So a lot of code was created in a very fast pace with lower quality. So therefore we think that it would be great to do something about that. And we actually introduced the platform team. I became the head of the platform team because like our mission was to create the environment or build the environment when developers can write or create better software faster. Currently, I run multiple platform teams, including infrastructure and security platform, as well as some production teams regarding search and data acquisition. So let's quickly jump on the agenda, basically what is ahead of us today. I will start with the KiwiCom intro and overview of the architecture. So basically how we are working, how the product is working, and basically who we are. Then I will be describing some details of the incident which occurred in March this year about the fire in the data center of OVHcloud. I will then zoom in a bit on the impact of Kiwi.com services and what we basically did after the incident and how it looks like. Then I will be talking more about the steps we took like years before this incident happened and how it actually helped us to survive this kind of incident this year. I will be talking more about the theory of the like best practices for the resiliency, as well as like choosing and implementing the resilient systems. At the end, I will try to like wrap up the key takeaways, and then there will be a Q&A. So let me start with the Kiwi.com, who we are, what we are doing, and why we are so unique in here. So we are virtual global supercarrier. So what does it mean? We basically would love to provide the seamless travel experience from whatever place A to whatever place B in the Earth in our application. So basically we try to combine all the airlines and all the other carriers and get the best possible itinerary for you and give it to you like seamlessly. We also invented the virtual interlining, so we combine and sell the tickets from the airlines which are not cooperating together, and therefore we are able to find a great price for this kind of itinerary. So for example, if I would love to fly from Prague to New York, it would cost me, I don't know, $1,000. But if I take some like other trip, so I can go from Prague to Milan and then from Milan to New York, and I'm able to get this itinerary for example, $400. So this is very unique what we invented, and this is basically what our customers allow. But let's have a look how it all started. Our founder and CEO, Oliver, has the idea about the combining the airlines which do not cooperate together in 2011. And he was basically looking for the holidays for himself, and he spent like multiple days trying to find the best itinerary how he can get from Prague to Porto. So after the holidays, he thought that, well, there must be the better way, and he based the company. In that time, it was called Skypicker. So we had a couple huge milestones in our journey. So in 2014, we acquired the MetaSearch visionline.com, which provide us to boost users and revenue. In 2016, we rebranded to kiwi.com, which basically enable us to have like more B2C business, and also to not be like clearly focused on the air tickets or plane tickets, but also on the ground transport. In 2019, US hedge fund General Atlantic came on the board and tried to help us to be the ultimate travel application. And how KiwiCom looks today. So currently we have like more than 500 people in R&D. We are like pretty young company. The average age is 31 years. We are a really multinational company. We have like huge amount of the nationalities on board, and also we are like dog-friendly company. So we have more than 140 registered dogs, which are like kind of bit here in the offices. Regarding the business numbers, we sell like more than 100,000 seats weekly, around 50,000 bookings weekly. And just to imagine, like probably from the infrastructure perspective, we have like more than 5 million searches weekly, which are going towards our website. We also cooperate with a lot of partners. So currently we have like more than 900 partners which are trying to cooperate with us. So our technology actually unlocks the key features. So currently, like using the best technology what we can have, we have the very nice inventory and very complex inventory, actually most complex inventory in the world. We provide also great search. So we have like multiple filters there. We can do very, very user-friendly searches for itineraries or to inspire them to travel and so on. And we also have very interesting features like multi-city. So in case that somebody would love to visit basically more cities, they could basically set the dates, and KiwiCom is finding the best itinerary. And the very interesting feature also here is Nomad, which is like famous informatics problem and basically traveling salesman problem. So it gives us the shortest possible route that could visit each city exactly once. So for example, if people would love to, I don't know, travel through the Americas, so they can put like multiple cities there, they don't care that much like when they are going to be in those cities, but they would eventually be. And we are able to provide them basically the best experience, so looking for the cheapest possible combination and so on. But to enable those features, we will need to be ready, and our infrastructure need to be ready for those. So let's have a look on the infrastructure and basically how KiwiCom is working under the hood. We are a cloud native company. We are using heavily like cloud possibilities, and we are heavily using all of the possible like managed service. We try to always write infrastructure as a code to have like easier maintenance and to have like better ways how can we change things in case that it would be needed. We have microservice oriented architecture, and we have like more than 600 microservices which are running the kiwi.com, and all of them are aligned in the specific business domain in order to like fulfill customer needs. But now let me focus more on the core of our services, which is the main database, which is storing all of the itineraries we are going to sell, and the name is Scylla. Our database store, our main database store, like information about all our flights, and the prices, availability are changing like super fast, and it's actually changing like multiple 10,000 times per second. So we need to keep track of those changes and always trying to recalculate the itineraries and looking for the best possible like solution or possible path we can give to our customers. Just for the sake of magnitude, our main database is running like more than 100,000 reads per second and more than 200,000 writes per second. Also, we have like very specific use case for our database. So usually like companies are using the database as an append only, so adding more and more entries into the data storage. But we have specific use case that we are rewriting the basically entire database on average every 10 days. So the prices, availability, and the possibility how to travel are changing that fast that we are able to rewrite it all like within the 10 days. Regarding the architecture or the infrastructure where we are run our services, we are running mostly in GCP, which is our main cloud provider. We run them like many web services, many like smaller SQL databases and so on. And we are using OVH as a like main bare metal provider. We run there our main database, Scylla, but also some supporting services around it, which basically communicate directly to the database. If I do basically zoom in on the architecture of Scylla, we are having like 3 data centers in OVH. One is in Strasbourg, one is Roubaix, and one is Limburg. There are like more than like basically hundreds of kilometers between them. And then we have like some services which are running in those data centers as well, and they are communicating via API, via gRPC API in web services in Google Cloud. Just for the sake of like interesting fact, the latency is like less than 1 milliseconds between all of 3 data centers here. Now just the view like how it looks like on the map. And so we are having like small triangle around the Luxembourg. So that would be it to describing like who we are and how do we actually operate our services. And now I would love to focus more on OVHcloud Fire and the events of like 10th of March 2021. Yeah, so as you can see from the picture, it didn't look very, very great. Servers came like literally on fire, and it happened basically after the midnight in Strasbourg in France. And basically the damage was huge because like a lot of websites and a lot of intranets were hosted there. So if we are talking about the damage assessment, the Strasbourg impact. So basically, there were like multiple data centers, multiple sections of the data center affected. So SBG2 was totally like burned at the beginning. With SBG1, which is the another section, like some of the rooms were executed. And some of the other section of the Strasbourg data centers were proactively taken down. As for the impact, it affected at least like 3.6 million websites, multiple hundreds of thousand domains, and basically it has like a huge impact of the French internet or like French domains. Because obviously, like a lot of companies there were using the local cloud or local bare metal provider. Yeah, here's some quotation from the NetCrowd that the website that went offline during the fire included online banks, webmail services, news sites, online shops, selling PPE against the coronavirus to several countries, government websites, and so on. So basically, we can see that it was huge and huge in the matter of the entire internet. But let's now be talking more about like how we as Cubicom like responded to the fire. So as for the zoom in, we had basically 3 data centers where we run like our main database Scylla, and one of them suddenly like has kind of disappeared. But what is the outcome of that? That we were fine. Our production was still up and running. And let me describe like more details about what we did like immediately after that, and what we were actually like doing in order to mitigate it more. So as you can see on the picture, 10 of 30 servers became suddenly unavailable. Basically, many other servers also dropped. So it wasn't just about the Scylla, but other supporting systems around that. But the Scylla just temporarily increased the latency because they tried to kind of replicate the load, and we were like up and running, and we were kind of fine from the customer's perspective. Regarding the timeline in the fire, so around the midnight, or like after the midnight, obviously, the fires break out in OVHcloud in Strasbourg. So we got woken up. We were trying to working on the systems around that because we had like more services running there, not just Scylla, but still production was operational, and we were quite okay. We just deployed during the night some tweaks actually to balance the load, but still it was like degraded performance, and we were okay. Yeah, as I said, we had degraded performance on some services. We try to rebalance the load by tweaking some services. Some services we had to actually move to the different place, and we have to like basically checking the monitoring like semi-manually. But for our customers, we were still operational, and everything was fine. And let me share the picture how our main database handled like one of the data centers, one of the 3 data centers outage. So our primary database, Scylla, was just fine. Yeah, but this basically is kind of like success story, happy ending, so on. But in our case, if we wouldn't be prepared like this, it would have like much more worse impact, and we would need to be like doing like a lot of steps and a lot of manual work in order to mitigate it. So let me share the story, like what would happen if we wouldn't prepare like that. So from the customer perspective, what would be the impact? They basically couldn't use our service, even though it's like main database, and we have like another like hundreds of microservices running in GCP or running in the cloud. Without the main database, we wouldn't be able to sell anything. We wouldn't be able to process changes in the booking. We wouldn't be able to provide good customer support. So imagine you are at the airport and you're trying to like call to the customer support because a flight might have been canceled or whatever else, and we just would be basically down and wouldn't have any possibility to contact us or to do something about it. So we would need to basically wait. Our customers needed to wait for our customer support or for us to get the systems up and running. And what would be actually the technical impact? So as I mentioned at the beginning, that we have the microservice-oriented architecture, and we are running like more than 600 microservices, which are kind of structured in the domains, this should be having probably the domino effect. So if the one service would be falling, there would be another which are dependent on the first service would be falling, and so on and so on. So basically, we would end up in like pretty random state when something is working, something not, and it would be very hard to get it up and running. Regarding the issues, we would need to like stop some services in some specific order to like at least stop the domino effect, and see how this might be working, how this might be actually affecting the production system, and so on. As a bottom line, this would be probably generating a lot of inconsistencies in data. So our data quality would be like falling totally down because some of the services might be working and might still be using the databases. Some of them are not, and this would be like affecting customers. And from those states, it's very hard to kind of fix it afterwards, because we would need to like we would need to run through the logs and checking the data, what was actually written, what wasn't, and so on. And in this scale, like 600 microservices, that would be the total nightmare. And yeah, customer support systems would be also overloaded because basically we couldn't get any details about the flights, and basically wouldn't be able to see like what is going on, and our hands would be tied, and we couldn't help our customers in that case. So how we would be probably handling the situation? So as I mentioned before, we would need to stop some services in very specific order. Then spin off new clusters, or spin off new servers. And it seems easy in this cloud era and with a lot of providers around. But in that time, basically, all of the affected customers were trying to like look for the free servers where they can go and they can like basically reroute the traffic. So even it seems a bit easy, it might be pretty difficult like during the outage, and this huge outage, to get the free servers or the servers we would actually need and would like fulfill our need. After we would like spin off the new cluster, we would need to let the database sync, because we have currently like data in 2 data centers or like whatever data centers, and we would need to have the consistency around the clusters. Then we would need to slowly start running the data refreshers. So basically to getting the new fresh data about the flights and about the itineraries. And then one by the another slowly start the web services for the customer. So web page managed by booking session, customer support systems, and so on. If I would be talking about the like estimation, like what could it cost? So there is like obviously like huge revenue loss, which is like direct impact, but even bigger like indirect impacts, which is like reputation lost, which if they could come to Kiwi.com for the first time, they could like basically go to the other side and never come back. This is also like huge issue for the like customer lifetime value, and a lot of like inconsistencies in the data, because we had to do like a lot of manual work in order to fix that, and it might be taking maybe weeks to get the all the data in consistent state. Let me it was kind of like happy ending story for us, but this wasn't done basically for free, and we had to take a lot of steps in advance to be this prepared for this kind of incidents, and be kind of ready if something happens, that what we are going to do. So as I said, like the resiliency during the disaster, that meant we had to be prepared years beforehand. It's important to plan in advance for like whatever incident. Usually it's not the matter if that happened, but when that happened. And we already like experienced some kind of like natural disaster. It was like flooding of the data centers and so on. So we really wanted to be sure that if we are going to build something like that, it needs to be resilient. So we were actually facing two questions. So what kind of technology should we use to order our needs? So it should be definitely high available architecture. There should be great data replication for the resiliency. But this is just the one of the point. We also needed to like choose a cloud vendor like very properly, because it's just not about the technology, but it's about also the geographical distribution of the data centers. And this is just for the like preparation part. What kind of technology should we use? Also, it's more about that, like what kind of procedures we have in place, and how we can use that procedures in the right environment, in the right culture. So how we get there? As I mentioned before, the requirements were kind of like high resiliency to provide the best value for our customer, and low latency to enable products like Nomad, multi-city search, and so on. So as I was mentioning before, in the history, we came through like basically many solutions before. And with the startup times, we started with the Postgres databases. So we kind of have like 40 or something like that Postgres databases, and we were solving the sharding actually on the application level. So this caused us a lot of consistency issues because it wasn't the solution for us, and it basically didn't scale with us. Then we managed to migrate to Cassandra, which was like way better, but we couldn't tweak the Cassandra to have like low latency and the good stability at the same time. So basically, the Cassandra wasn't able to scale with us as we would need. So therefore, we choose Scylla, and we choose it for the like high availability architecture, for like higher resiliency, and for the possibility to tweak it as we would need. So Scylla has peer-to-peer leaderless architecture, so there is no like single point of failure. We can also control the replication factor. So currently we have that set for replication factor 1, but we are actually using like three data centers. So we should be having the same data in the different data center, and this is basically what help us in this outage. It has basically a lot of like various tweaking kind of thing is what we can affect and create the service as we would need. So it's basically resilient by the design, and it's also very tweakable. Okay, so now we have technology, and what is the next to have the resilient system? We needed to have a plan. So that's just the picture from the starting of the implementation of the Scylla. And this was the like first draft of the architecture, and obviously we chose that good because we were able to survive and mitigate this kind of incident. And like having and building the resilient system is not only about the technology. It's pretty important part, but it's not only about the technology. We also need right team and processes in the place. We basically need to unlock the advantages of the technologies via the team, because if the technology is there and we are not able to use it properly, it's basically nothing. And the best way to set up this is create the culture, which is trying to like make the great team to use all of the advantages of the various technologies in order to fulfill the customer needs and in order to help business grow. Pretty natural part of this is incident management. In the dark startup times, we had a lot of heroes here. So we had a lot of engineers which were hackers, which could fix everything in the middle of the night from the bar, and they precisely knew where to look on whatever server they should SSH, and how can they fix that. But this attitude basically didn't scale we need to start handling like incidents properly, because it's not like, first thing first, is not, we are not able to get, I don't know, 300 hackers like this in the company, and also the knowledge sharing is very, very limited. And if somebody is actually fixing the incident like this, like from the bar, basically there is close to zero visibility. So the other day, nobody knows that maybe there were the outages, and what we can do about it. So first thing first, we need to start putting the proper monitoring in place, and it goes hand in hand with like proper alerting. It means that we need to have good visibility to our systems, and especially in this microservices-oriented architecture, where we have like a lot of communication between the services, to know like what is working, what is not working, and how can we handle the situation. We also need to put into place the incident management system. It was pretty important to have the visibility and transparency into whatever incidents which happen, which basically enable us to build the blameless culture, where anyone can learn from like anyone else's mistakes. This is probably the most important point of the entire like activities around, because if we create this blameless culture, we can then build on that like basically whatever. So when the incident occurs, and it occurs for sure, we still have the like base. How can we learn from that as much as possible? So this like ultimately leads to systems which are more robust, and it's building the culture that we are fine with presenting our mistakes, and we are proactively preparing for the incidents and for the handling of the incidents. One of like great techniques which is kind of working at company is the wheels of misfortune. Wheels of misfortune is the concept that basically people, it's like the game Dungeons and Dragons. So there are like multiple roles in the team, and we are basically trying to simulate the incident. So there are a couple of roles. So there is victim, there's somebody who is communicating what is going on, and so on. And people really enjoy that and learning a lot from that. Because, okay, you can have the documentation, you can have like great manual what to do in case that there is an incident. But if you are woken up in the middle of the night by the whatever system, by the PagerDuty, and then you have like a lot of adrenaline, you have a lot of stress, and then you can go to the computer and you don't have time to go through the like 20 different manuals, 20 different wikis. But you need to know where to look, what you should do in those cases, and so on. And to be prepared for a situation like this is pretty important to try that in advance, and trying to simulate all of the incidents as precise as possible. Yeah, I will be talking more about the best practices for the resiliency. So now this was basically our story, but I would like to actually have a perspective of like how did we get there, and what should be the theory behind that, and how we should choose what kind of practices do we need to have in order to build and have the resilient systems. So where to start? From my perspective, the key is to define what's the most important for the business. What's the systems? How can we find them? Like, do they rely on the same resources? What are the dependencies between them? So those are very like important questions we need to ask before we start like preparation for these kind of incidents. In our case, it was like pretty straightforward. We have like our main database, which like many systems are not able to work in without that. So we were try to like starting at that point, and then like put more and more services in that. Then it's very like important how we are going to implement it, because we might be having like multiple approaches, and I would try to like emphasize that it's probably good to not have it defined best on the first shot, but rather to try it, fail, and repeat. And basically the blameless culture and incident management with good postmortem process are leading us those directions. So we have basically two approaches what we can do. So proactive approach is that if we are ready in advance, so basically have more infrastructure, have fallback solutions, have backup lines, and so on, that the infrastructure is still running and waiting like for its opportunity. Or we have the reactive approach when we have like the manual or we have the run book, what we should do in case some incident would eventually happen. From the engineering perspective, engineers usually love automations, so they are pretty happy that if something is working without touching that, but they really don't like a lot of manual steps. But from the business perspective, I would say it's like other way around, because we need to be focusing more on the cost efficiency of the solution. So it's probably doesn't make sense to scale the infrastructure like 2 times, 3 times more, like in the entire infrastructure, but rather pick just the critical path and trying to have the proactive on those. It's important to not over-engineer the solution. It's good to think about the probability or the possibility of the risk and cost. And basically it's good to always like reassess the risk factors and the investment we put in place, because the systems could change over the time and we might not be having the critical path covered. So for example, in our case, we were prepared for loss of one data center like proactively, because we scaled that like over one data center. But we weren't prepared for 2 of the data centers. So in that case, that basically 2 data centers would fall down for whatever reason, and there will be some incident. We were prepared in the way that we would be able to spin off the new infrastructure in some other at some other provider. So we had basically the code with which we can run on GCP, and it was like create a cluster for us. It's not perfect, yes. But actually, I believe it's like right assessment of the possibilities of the risk. And regarding the overscale, it's often not about like overscaling the infrastructure or overscaling the service of like 1 instance of 2 instance. But this is important to overscale it basically a lot, because as we saw that many natural incidents could happen. So either it might be fire, might be flooding, might be like huge electricity outage, and basically we will be completely down. And regarding choosing and implementing the resilient systems, I would say that the overscale definitely makes sense. As long as it's like basically created or we are overscaling the infrastructure along the critical path. So what is critical for the business could be overscaled a lot, because it's a huge probability that if something happens, it was affected almost entire business. And the fallback solution. So for example, in networking, having the backup line is always like the good practice, but let's make sure that you are measuring it and you are always testing that to have it like up and running and to be sure that you can rely on that, because incidents like this, like huge and major incidents are happening like maybe once in many years, but the solution might have changed from that, and your business might have changed from the time you actually created the solution and so on. It's very, very important to try that. I would give an example here. It's about the chaos monkey. I do not want to go like too many detail about that, but the chaos monkey is the like product from Netflix, and Chaos Monkey is responsible for randomly terminating instances in production to ensure that engineers implemented their services to be resilient to instance failures. So that there is like many tools, many approaches like this, but it might be very, very good to implement it along the critical path to be sure that the resilient solution and the fallback solution are always tested and are up to date. Yeah, regarding the reactive solution, it's always important when something happens to be sure that the things are very well documented. So it would be great to create a plan, but same as the proactive approach, it's about the testing that, because those things are very often to be like outdated. Either the business might change, either some like external factors might change, and if you put the documentation in the wiki, nobody would ever read that because the incident didn't occur for multiple years already. You couldn't basically rely on that. For example, in our case, there's like specific run books of what we need to do in case that there's this kind of outage or this kind of incident or this kind of problem. Last but not least, I will be talking more about the culture and about the team's perspective. And let me quote Josef, our CTO and co-founder of Qubit.com. We are ever evolving, testing, innovating, learning, and moving on at fast, rewarding pace. And this is how we operate at Qubit.com. I believe that this incident and the entire response is a bright example of this quote, that this is actually really defining what we are and what we are doing in here. And for building the resilient system, it's very important to get the greatest team, to cultivate the right blameless culture and create the environment that people are not scared of admitting the mistakes, but they are always keen to always improving. And I would love to use this opportunity to thank them all because they did a great job and they helped our business tremendously. And same goes to your partners. So basically, if you have good partners, it's like a part of your team. And it's important to find the partners who consider your problems their own. And along our way, we found like a lot of them. I would just put like multiple of them in here. So it's OVH, GCP, Scylla, Megapod, Cloudflare, and the others, because we wouldn't be able to survive the incident like that without great support from the partners, great initiative, great proactivity from them, and like willingness to help us overcome those kind of problems. As the final remarks, so let me read some quotation from my favorite movie, Good Year, when Uncle Harry says, "It's inevitable to lose now and again. The trick is not to make a habit of it." And if I can rephrase that a bit, I would say that the outages are inevitable, and just up to us to be prepared. It's not the matter if the incident happens, but when the incident happens. So we need to always plan for the worst and hope for the best. Very important part is also to get the right balance between proactivity and reactivity, because we couldn't have, because probably it wouldn't be like cost effective to have like everything proactively backupped, proactively like working. But it's great to have the proactivity and backups along the critical path of our business and our system in the company. And last but not least, getting the great team and slowly cultivate the blameless culture. It's a way how to drive the innovation and how to drive like resiliency in the system at the biggest possible effectivity. So that would be it from my side. Thank you very much. And now back to Robert.
Great. Thank you, Stanislav. And I love that movie quote. Now, everyone, please stay right where you are. We will now be heading into the Q&A portion of our presentation. As a reminder, please put all questions in the Q&A panel located on the right-hand side of your screen. We'll see you in a second. Great, Stanislav. So kicking off Q&A, we've got a lively crowd this morning or afternoon, wherever you are. So first off, this is a three-parter. So can you describe your Scylla nodes, resources, and configuration, CPU, RAM, disk, OS, and kernel version?
Yeah, sure. Thank you very much for this question. It's pretty important to have a kind of overview about how the architecture looks like. So currently we have 30 servers, 10 per each location. And regarding the server, basically we have 40 cores there. We have more than 300 gigabytes of RAM in there. And we have 2 times 2 terabyte NVMe disk in the instance. So altogether we have around 20 terabytes of data in the entire cluster. And regarding the OS and the kernel version, we are using Ubuntu, something around 16, and the kernel is 4.19.
Okay, great. And then following up on that, what was your replication factor and consistency level for read and writes?
Yeah, as I mentioned, the replication factor is set to 1 because we do use replication between the locations, and about the consistency level, it's also set to 1, both for reads and writes.
Got it. And about what was the size of that data on the cluster?
Yeah, it was 20 terabytes in total.
Great. So following up another attendee, what did you learn from this experience, and what are you going to prepare for possible, similar disasters? Hopefully, no more fires.
Yeah, I hope not. Regarding the learnings, basically with the database we hadn't that huge issue. So as I mentioned in the presentation, we have everything kind of up and running, but we identify some kind of bottlenecks in the systems which were like nearby. So this is something what we enhanced by the outage, and basically we've written the postmortem and we took the action steps. How can we have that better? So this is definitely the learning, and probably as an action steps, we might be trying to simulate this kind of situation in these big dimensions, basically more often, to see if it makes sense basically for us to maybe find different solution, like overscale this solution, or maybe put some fallback, like automatic fallback into it.
Got it. And then, obviously Kiwi is huge in Europe. What about Asia, the US, maybe some other markets? Any plans or info there?
Yeah, we are huge in Europe, but we have like customer from all over the world. But regarding the data, for now we don't have this strong, like basically business case that we would need to basically like share them between the continents. So currently we are happy with the solution, but I would say with the growth, what we expect, this would be definitely a question for the future review of the architecture.
Got it. And then transitioning, so you have a small data footprint. Are you caching at all?
Yes, there is basically like multiple levels of caching, or like depends like what kind of data. So we are still like playing around, for example, some real-time engine. We are using it in the production and so on, but actually we are using this database mostly as our cache for the like raw flights. So we are having like caching in the like web platform and so on, but regarding other layers of the caching, we don't have something like that.
Got it. And then another question from an attendee. You can spin a new cluster in GCP, but what about data?
Okay, not sure if I understand the question. We would need to probably, like by the spinning of the cluster, we would need to wait to load the data into the cluster and to have basically the same data in all the clusters as for our configuration. So I'm not sure if I responded to that, but feel free to put me.
Great. And then could you please share some details how it solved the worldwide load balancing architecture between data center clusters from a resiliency perspective?
Yeah, I'm also not sure if I understand that. Well, load balancing architecture between data centers. Okay, I will try to think like how we would basically amend the architecture in order to have like better latency all over the world, if in case that would be possible. I hope that will be respond to the question. I think that it would be great to have like multiple like data centers across the world, and try to route the traffic, the production traffic to the nearest one. With something like this, we would need to more elaborate even on the application level, on the either like eventual consistency, or we'll be playing about the loading of the data and basically about the accuracy of the data. But this is really, we don't currently have the like real use case for that, so it's something what we will be playing for probably in the future with it.
Got it. Okay, great. And then some more questions coming in. Let's see, coming in from attendees. So here's a question. So for Postgres, it's supposed to be highly consistent, but you said it gave you consistency problems. Can you explain that a bit more?
Yes. So in that time, it was like 4 years ago. We used to have like more than 40 Postgres databases, and we were actually solving the sharding on the application level. So this was something which is like not really standard, and it was very hard to maintain from like basically our point of view. The thing is that Postgres is like more relational database. Definitely, it used to be more in the past. And with those raw, like let's say flight data or itinerary data, it's better use case for actually NoSQL database. So this is something which made us like think about if we are like using the right tool for the right problem, and then we start actually look elsewhere. It's not about the problem with the Postgres itself, obviously like it's consistent and it's working fine, but for our use case, it was like really misusing the technology.
Great. And then another question from an attendee. So what was the biggest gap for your response? And how potentially could you do better next time?
Yeah. Regarding the gap, I would say that as I mentioned in the question before, that we identified some bottlenecks mainly in the systems around the main database. But from my perspective, it will be also like better to have like kind of more advanced monitoring, which would be basically sending us the data like way faster about all the affected system, as well as some like real-time monitoring, as I explained that we have the microservice-oriented architecture, and it would be great to see like what would happen if this one service goes off and what is dependent on that. So this is definitely something what we need to enhance in the future to have basically even better visibility and observability.
Great. Another question coming in. So ScyllaDB data modeling is based on the queries you would use. How hard is it to change your mindset from Postgres to ScyllaDB?
Yeah, that's very good question. Actually, a lot, because the entire transition towards the NoSQL database took like multiple efforts. It was like cross team effort, and we managed to like prepare some kind of service in front of the Scylla, in front of the database, which is actually like handling and seeding data to the other services. So the transition wasn't basically that easy, but we managed to like do that, like giving some microservice in front of Scylla, which is able to answer or like basically answer the simple queries, and then like all of the other applications do not need to like change their behavior that much.
Great. And then another question coming up. So you said you have a replication factor of 1 for Scylla, but 3 different data centers. So does that mean each different site has a complete copy of all the data?
Yes, it does. So basically we have the copy of like entire copy of the data in 3 different like locations.
Great. And then building off of that, do you have a recommended number of independent data center locations, making nice triangle shapes or any other shapes?
Yeah, I would say like with the higher amount of data centers, like it would be even better regarding the resiliency. But the thing is that we need to always think about the latency and about the traffic which is going through there. So for our use case, it's proven that this is working quite nice. If we would need to like lower the latency, or we need to do some like global infrastructure for all around the world, we might be thinking about like different numbers, obviously, and also like different type of the architecture. So maybe speaking about like we might be storing a portion of the data somewhere else. We might be storing some local data in some specific location, and so on.
Great. And then building off of what you talked about earlier, how often does your team meet to go over resiliency planning? Is that something quarterly, once a year? How do you do it?
Yeah, basically, I would say that if we are thinking of that, I would say on not like daily basis, but definitely like would say monthly basis, because the business is changing and we need to always like reflect what kind of needs there are from the business perspective. So obviously with the main database is like huge change, but we are still trying to do like some AJ applications. So we are trying to always like strengthen our infrastructure. I don't know, with multiple clusters deployment by default and so on. So it's something we try to like build the resilient systems by default, and usually like we are thinking about that like always as we are going to like create a new application. The difference is only with the level, like with the scope of the entire thing. Because if we are building or if we are creating something that big as the main database, we need to definitely think through all of the details, how that would make sense, how it is affecting the other systems, and so on.
Great. And then how large was the team working on this database, and how many of them were directly involved in your disaster response?
Working on the database, so I would say we have like let's say 5 to 6 people from the infrastructure team when we start like building the plan and doing the initial setup and setting it up and running. Though, but this is not all. We also need to like put in place some engineers from the team, which are like the most heavier users of the database. So we actually did that. So that was like plus 2 people, and then we actually create some like small to medium sized team, which is doing the service in front of the Scylla DB, which is like handling the transaction better and so on. So in total, for the preparation phase or for the migration phase, I would say it might be around 10 to 12 people. Regarding the disaster, so like there were like multiple people were on call. So I would say like it was solved by 3 or 4 people during that night.
Okay, great. And then in terms of getting a notification about the outage, did Scylla notify you directly, or was there another tool that you used for this?
No, actually, it was our own like monitoring system, and mainly it was the monitoring system from the systems which are around the database, which were also part of the data centers, which had this incident. So it was like the database, as I said during the presentation, was like kind of up and running, but we need to tweak the services around that. So we got notified from the services around the database.
Got it. And then, a last question here, I think, as we're wrapping up Q&A for today. Potentially, theoretically, Stanislav, what would happen if you had lost a second data center?
Yeah, that would be probably very, very unfortunate for us. No, I mean, we might not be in that case. We might not be ready to handle all of the traffic with the one data center, and we would have been going probably with the plan that we would try to spin up the new data center as soon as possible. So basically, with the way that we have prepared the steps, what we need to take, and we would just basically go by the runbook and try to get the systems up and running.
Great.
So as for the like final thoughts, that's we are not kind of like ready for like losing 2 data centers at this stage, but like not proactively, but rather reactively, that we know like what would be the exact steps or if that would happen, what we would do.
Great, perfect. Well, thank you so much, Stanislav. This was a great webinar today. We were so excited to have you join us today. And then thank you all for being with us this morning, afternoon, evening, wherever you are in the world. Just some quick housekeeping items. This webinar will be available post-event. Be on a lookout from us with a link to the video. And also feel free to follow up with any questions you have for Stanislav or the team here at Scylla. And wishing you all a great rest of your day. Thanks.